Test, test. Cool. Great. All right, it's time. So let's start with the class admin today. First, let's talk about the most important thing, which is the course page. Yesterday, you've seen the QR code that takes you to the course page. What I'm going to add a little bit is just that there's another way which might be slightly easier if you want to find the course website on the road where you don't have the QR code convenient. The way is to do this. Just Google Poly, okay, and you should be able to see Poly's webpage top as the search result. Click on the teaching link in my page, and then you should see a category called the Introduction to Computer Networks. And there's a small link underneath it said Spring 2020. Click there. That takes you to the course page as well. And let me demonstrate. How about that? This is the course page. Let me bring it up. Oh, wait, it's not yet the course page. So this is a new page. Okay, so that's Google Poly. And Google should be telling you, hey, this is Poly's link. Click into it, and then you'll find the teaching link up here. Click underneath the undergrad courses category. You should see this course, Introduction to Computer Networks. And click on Spring 2020. That takes you to the course page as well. All right. Let's move back to the lecture. Now, real administrative information. There's not going to be any physical meetings, which means we'll all be meeting in the cyberspace. So YouTube for the lectures, and exams is also going to be online as Google Forms. Lecture hours, Wednesday 11 to 12, Thursday 10 to 12. Note that there's a break in between the 2 hours on Thursday. Poly does need to go, take a break every now and then. Now, make use of the time. Type up questions you have for the first hour during that period. When Poly comes back, I'll see if I can address some of them, okay, at the beginning of the second hour. I'm Poly. My office is also in the Berry Lam Hall, where we had the physical lecture yesterday. My office is up on the 6th floor, so take the elevator up or take the stairs, in this time where we have the virus situation. My phone number and email address is as shown here on the slide, 3366-3599, or better, send me emails. That is usually the better way to find me, and I correspond fairly fast over email, hopefully within a day. And you just saw where my homepage is, and there's an easier way to do it than trying to memorize the URL. Just Google me. There is an office hour every Thursday right after the lectures. So that's the lunch hour as well. So for some of you, it might not be very convenient. Feel free to send me emails to set up appointments. And the way we'll meet for the office hour is through some sort of live chat software. FB Messenger will be convenient since that I'm already part of the FB group. It's easy to find me. But I did reject all the messages from non-friends. So if you did try to send me messages there, make sure you write me an email, let me know, and I accept your message. then later on it'll be easy for you to message me without making me your Facebook friend. Okay, I know it can be awkward sometimes to connect with our professors as friends, and it's sometimes awkward for me to connect you guys as friends as well. So that you know. There's going to be a TA this semester. The name is Caleb. His office is also on the same floor. So it's just across the hallway in room 621 from my office. There's the email address of Caleb, and he's going to join the Facebook group shortly after the lecture today. So feel free to try to find him and ask questions as well. If there's anything that he doesn't quite know how to address, he's going to contact me, so don't worry. Now, the first serious content today, the content of the lectures throughout the semester. First, the nature. This is gonna be your first course on the internet, but some of you might have known the internet to some degree. That's great, okay? But what I'm trying to say there is that I'm not assuming you know anything prior about the internet. So there's no prior knowledge required. And then, but be careful, the course is actually designed for EECS students. What I meant there is that I'm going to be using terms, technical terms, that EE students should have known already. So those are to say this. I am expecting that you have taken these two courses that are very fundamental. First is Introduction to Computer Programming. If you have something equivalent of knowing a programming language well, that is fine. Okay. The other course, Introduction to Computers, sometimes this course is also called the Introduction to Computer Science. Okay. What I meant there is that you do need to know there are these hardware components inside a computer. You see CPUs and memories, and the CPUs and memories being connected through buses. And the buses is also used to connect to other peripherals like keyboard, like network interface chips. Okay, so that is the component that's very, very relevant for this course. And beyond that, there's also this operating system thing. It's the system software that's actually trying to control all these hardware components, trying to also manage these hardware resources. As a result, all these applications running on the top that we're using can then work seamlessly in parallel. All right, so that is the things that I'm expecting, and I'll be using terms like bus, CPU, memories. I do expect that you know these well. Some of you have already taken courses like data structure and computer programming. That's great. You're going to do well here. Objectives. Now, I'm expecting you to learn not only the hardware components that's forming the internet, the terms to referring to these components. What I'm going to be teaching as well is that you learn the mechanisms that are communicating these components. And it's usually not going to be just one mechanism to allow these components to interact. There are usually multiple alternatives. So in the process of learning them and comparing these alternative mechanisms, you will see also why the internet chooses to implement one over the others. Okay, so what, how, and why. The scope, simply put, the internet. Okay, now you're seeing a new term here, data network. Okay, so data network is a term that we use very often to refer to the internet as well. Now, the flow is going to be like this. We're going to learn through what internet is by the layers. Okay, at the top, the application layer, transport layer, network layer, gradually down to the link layer. Okay. Now, normally in other semester, we'll have some time to cover these new and hot topics, mobile wireless networking, multimedia networking, but unfortunately this semester, the time is a bit short, so please excuse the special situation. Next, the schedule of the semester. This is the first half. All right. You will see that this week is mainly the class administrative information, and then we're going to go ahead and start and introducing you to the internet. Okay. So the overview part is going to take 1.5, maybe slightly more, and spill over to the third week. But generally about 2 weeks of overview, and then some 3 weeks of application layer, and 4 weeks of transport layer. Okay, but we'll be covering only the first half of the transport layer in the first half of the semester, and then we'll have the midterm exam. Let's move on. The second half looks like this. We'll try to wrap up the rest of the transport layer and then spending 4 more weeks on network layers. Now, in fact, on the weeks 14, chances high that we finish network layer a bit earlier. So we'll be starting link layer here and then try to finish link layer, which is substantially easier and narrow. So it's going to be 1 week or 1.5 weeks. And lastly, the final exam. Now, the university actually regulates also that officially we still need to teach 18 weeks. But due to the very special situation, and we do need to report grades by week 16. So most of the classes is designed such that the load for weeks 17 and 18 is somehow distributed over throughout the semester. Now let me, flip the slide back 1 page. You'll see, hey, week 2 to week 7, at the end of it, I'm saying this, PA number 1, PA number 2. PA stands for programming assignment. So you see that it's actually quite intensive. Every week you need to turn in the solution for each of these assignments. And in the second half, there are only 3 programming assignments, but these 3 are actually more challenging. So you're going to spend more time on it. Therefore, it's actually 2 weeks apart before you are able to finish the program. So the programming assignment part is quite intensive, and that is to make up for the load that is actually required in week 17 and 18. So that's just to explain why I only talk about 16 weeks of lecturing. Now, the second part of the admin info. And this is going to be taking some time, so just be prepared. Let's start from this. The grade. The grade you'll be learning, 35% of them is going to come from this, the programming assignment. As you see that it's going to take quite a bit of your time. And as I mentioned in the first part of the admin info, that this less interactive type of lecturing makes it hard to learn things. But it's actually perfect for learning a programming language. So let's do that to make sure that you at least learn something. And then 20% is going to come from this, the take-home quizzes. Okay, so the quizzes used to be in class, but unfortunately we'll have to do this take-home. So for the quizzes coming up, I'm going to just explain to you what I'm asking there for the quizzes. And you guys will go to a specific place to post your answers. And that's going to take 20% of your effort this semester. Participation, 5%. So it's actually lower than what I used to ask of, because also of the very non-interactive way of lecturing. Now the 2 exams, each 20%. So if I group them based on whether this is a result of teamwork or individual effort, you see programming assignments and take-home exams, take-home quizzes are part of the teamwork. Individual effort, together, 45%. And you see a little bit that, hey, teamwork is actually weighted a bit more this semester. So, very important thing you do. The first thing you do as well, try to form your teams. Now, over the years, there are more and more students asking to work alone. Well, you know what? I'm going to allow that. So, loners allowed. You can form a team of 1 student up to 3 students, but not more, please. All right? And these members are going to work together throughout the semester for the PAs as well as the quizzes. Now, very rarely, some of the teams will be asking if it's possible to break up. Okay, that's also okay. Just be careful. Working alone as a 1-person team, the load could be pretty high. Just think about these programming assignments. And beside that, every week there's going to be 1, maybe more quizzes. And some of these quizzes do require that you think about it and then doing all these postings. They do take times. Now, I'm gonna go through all of these, all of these items that you'll be receiving credits from. So first, the programming assignments. So the assignment is gonna be running on Unix, and it's gonna be using this language called Go, and the programming language is actually large. Okay, there are many APIs, some for arithmetics, some for creating loops, and we'll be focusing on these APIs allowing sockets, okay, allowing computers to send messages to each other. Okay, so it's going to be Go-based socket programming, and the submissions are going to be in electronic format. And this semester, because I run into situations like this a lot. Sorry, professor, I actually forget about the time to submit, and I'm only 2 hours late. Can I get partial grades? So this semester, I'm gonna experiment this, different way of grading the late assignments. So what I'm gonna do is to introduce a penalty if you're late. So late assignment is allowed. You'll be graded. You will also receive a grade, but the grade will be partial of if you're submitting on time. All right. And so the policy is this: if you submit within an hour beyond the deadline, you receive only 10% of penalty. So your normal grades, if you submit on time, and subtracting 10% of that. Now, if it's within 6 hours but beyond 1 hour, 20% being deducted. If it's later than 6 hours but within 12 hours, 40% deducted. Within a day, 80% deducted. But if you submit later than a day, sorry, you receive no grades. So essentially, don't bother if it's too late. Now, what are these programming assignments? Stage 1, you saw earlier, this is going to happen the first half of the semester, okay? And I'm planning these PAs such that it's continuous, okay? And every week you need to exercise something. So first of all, PA1 is, hey, for you to log on to the Unix server where you will be uploading your assignment, where you also need to compile your code and test it out. Okay, and the reason for this is that you guys will be all working first locally on your own machine, and you'll be downloading a Go compiler from somewhere. I'm actually not quite sure which version of the compilers you're downloading. Okay, well, chances low, but occasionally you might be working on a newer version that it works, but when it's compiled on an older version, it might not work, or vice versa. Okay? To ensure fairness, to ensure that there's no accident, please upload the code that you have finished to this workstation we've already set up. Compile the code there. I've already installed a Go compiler. Use that compiler to compile and test your code out, okay, again, on the workstation. Make sure that it works, and then you'll be safe. Now, in order for you to access the workstation remotely, it's a Unix-based machine, and you're gonna use SSH, a secure shell, to connect. So you need to be familiar with all these basic Unix commands. So PA1 there is designed so that you get to learn these commands and then play with it hands-on. PA2, we'll start with Go. And this part of the assignment is to ask you to exercise the file access APIs. How do you read from a physical file? And how do you write a string onto a physical file? So accessing files. As later on in PA3, you'll be writing a client program that uploads the content of a file. So it's a file uploading client essentially. In PA4, well, you switch role. Now you have the file upload client. You now implement a file upload server. What it does is to accept messages coming from your file upload client and store it as a physical file in the remote machine. All right? And in PA4, what I ask you to do is just to do one upload, and then you can close your server program. Now, PA5 is to extend PA4 a little bit further so that it allows multiple uploads. So your server will be looping forever, allowing the client to upload not just one file, but more files. All right? And then PA6. PA5 there is a server allowing one client to do multiple uploads. What if we have multiple clients wants to do upload at the same time? So PA6 there is to extend your PA5 server such that it allows clients to do simultaneous uploads, which is more like what the servers are doing these days. Good. Sorry guys, I'm not able to see the live chat because I'm in this desktop mode. I'm seeing just the slides. You might have questions. I'm actually expecting you to ask questions. Feel free to type them up. During the breaks, I will have some time to go over it, and I'll see if I address the questions then. All right. Now let's move on. Second stage of the programming assignment. Now you'll be seriously implementing a web server using Go. And the first part of it is that build on top of PA6. Okay. Now you'll be interacting, so your server there will be actually interacting with the web browser, a regular web browser, such as Google Chrome, such as Firefox, such as Safari or IE. Okay, so your client will be one of these browsers existing. Now, these browsers is gonna send you messages in this form called the HTTP request. Okay, so HTTP is the protocol that's running underneath World Wide Web. Okay, so this web request that's coming into your server, you need to manage somehow, interpret it, and find out exactly what the user is requesting. But luckily, I'm asking you only to handle a request for an HTML page. Okay, so, but still you need to be able to interpret the HTTP request and know that which HTML file your user is looking for. So that is what PA7 is designed that you need to complete. PA6 then is to extend your PA7 server such that you generate a response. You can send back the HTML the client is looking for. And that unfortunately needs to be in HTTP response format in order for Google Chrome, in order for IE to understand, therefore displays the HTML page appropriately. All right, so that is PA8. And nowadays you see more is that many of the websites runs HTTPS, okay? That is secure web access. So PA9 is to extend PA8 server such that it works like a HTTPS server. All right. Now, in the second stage, as you heard, it's going to be harder, substantially harder. It will definitely need more self-help. So Google, go into Stack Overflow forums, search if there are already questions that you wanted to ask, and if there are anyone providing answers for it. And some might provide slightly lame answers. You will need to try it out and see if it works for you. But some might have brilliant answers. Try it out and it might work for you. Okay. Now the debugging process definitely requires also creativity. what I want to say here, the debugging effort is always underestimated. It's actually hard. You have to think things through in order to make sure that you get it right. All right, so that's hard part of the semester and what you need to do, and it takes you 35% of the time. Now, the next 20% is this. Oops, sorry. It should not be in-class quiz. It should be the take-home quiz, just, that I make a correction here. So the take-home quizzes. Now, these quizzes will show up randomly in the middle of the lecture, okay? Most of these problems are related to the topic that we're talking about. You'll be given time to work on it off class. Okay, so the answers you come up with, just feel free to post it into the FB group. For each quiz, I will upload the picture of it. Just post your answer underneath the picture as a comment. So to fulfill this requirement, post your answer as a comment by the Friday next week. Okay, by the Friday next week. So if I'm giving a quiz this week, then make sure that you finish it by next Friday, 6 p.m. And this is no late assignment. If you submit late beyond next Friday, 6 p.m., it will not be accepted. So just don't bother submitting it. All right. And some of you might submit earlier than the other. That's great. Okay, so first submission receives some extra participation points. And unique sharing. So if your answer stands out very different from the others, you also receive extra participation points. All right. And in the end, whether you receive the full 20% of the grades depends on how many of these quizzes you complete submitting an acceptable solution. Now, next class participation, you heard me that if you submit answers for the quizzes earlier, as well as being more unique, different, you receive extra participation points. Now, if you ask questions live on the chat or offline on FB groups, particularly if you try to address other students' questions and it works beautifully for the other students, great, more participation points. All right. So although we cannot be very, interactive during the lectures, let's try to be more interactive using all these, online tools. Yes. Sorry, there's a knock on the door. Okay, so that's just my assistant, so I can go on. All right. Yeah. Oh, by the way, whenever you're trying to say something, identify yourself. And I see that on live chat, I see your ID. On Facebook, I also see your ID. But you see that it's also better when you're posting on behalf of a team, you state your team number. Okay, if it's posting answers for a quiz. Now, as I mentioned, any interaction counts. Interaction over FB, YouTube, emails also works. Contacting Polly for office hour, having a live chat, that also works. Interacting with Polly counts. Interacting with the TA also counts. Okay. Now, some of you, click on likes and saying things like, "Hi, how are you today?" Well, those count as well, but hey, they count less. All right. So try to be more constructive, participate more by addressing hard problems. So in a way, the participation part of the grades also shows the amount of efforts that it takes to generate these interactions. In the end, we'll be grading on curve, meaning we'll try to scale those who have the minimum participation to the maximum participations, and we'll scale them across the 5 points that we'll be giving out, the 5% of the semester grades that we'll be giving out. Lastly, the exams. Well, this part is easy for me to explain, but you might be a bit anxious about these exams. So as I mentioned, there are in question and answer. Some might be a bit more open-ended. Don't worry, all exams are all available from the course page. You can actually scan through some of them and see how challenging or Some questions might not be all that challenging, so you get a good feeling of how the exams are going to be like. And each is going to take 20% of the effort. And by the way, there's no early or makeup exams. And this is particularly the case for this semester because the exams are going to be also online. And they're gonna be in Google Forms. So it doesn't matter where you are physically. Yeah, partly about the exams integrity. No cheating behaviors involved. If you get caught, 0 for the grade. And according to the regulation of the university, we need to report your case to the department and the university. There's something extra they deduct as well from your, other grades. Okay, so I mean, Chinese or Taiwanese universities also give these grades about, how you guys are behaving morally speaking. Now, hey, about giving zeros for exams if you caught cheating. Polly is not nice. When Polly says something, she's gonna make sure that happens. So don't try this. What I want to say is this: when I was growing up, okay, I was tired all the time, being told what to do. All the time, I want to be more myself. More the time that I want to speak of my mind. But unfortunately, sometimes when I speak too honestly, that kind of offend people. That sometimes also disappoint people. But hey, you don't have to worry about that. Feel free to speak of your mind. Feel free to speak what you know, what you don't know. There's nothing wrong with that. Okay, just tell me honestly what you think. Write honestly what you know. Polly will not see you any differently. By the way, and for the record, and it's recorded, Polly is gonna love you no matter what. Okay? Hey, I'm a woman of my words. Okay, I'm gonna just hold on to my words. Okay. Okay, so that's your responsibility and the grading policy. Lastly, the class material. There's going to be a textbook. It's highly recommended, by the way, Computer Networking, a Top-Down Approach, and we'll be using the 7th edition. Authors, James Caruso and Keith Roth. It's very well written with quite a bit of pictures, examples, so it's easy to follow. So if you don't catch too much of what Polly is saying, if you prefer reading rather than watching videos, yeah, this is definitely the material you want to dig into, and you can go as fast as you can. Okay, and if you have questions as you read through the textbook, feel free to come ask us. Now, there was a question at the end of the physical lecture yesterday. Some of you are concerned because buying a brand new textbook could be expensive. Yes. Try this. Okay, having a book around you is very convenient, and that's going to help a lot. Okay, so try if you can find a secondhand book, okay, from somewhere. So ask your local friends and see if they can refer you to some local chat rooms or discussion forums where students are exchanging secondhand books. Now the trouble there is you might be getting a textbook that's an early edition. For example, 6th edition, 5th edition. That actually should serve the purpose just to make sure that you cross-check the organizations of the chapters and sub-chapters between the editions. Make sure that you are following the lectures the way, the same flow the 7th edition is ordered. Okay, so there's some, I think, rearrangement of the sub-chapters between the 7th edition and the older editions. So just keep that in mind a bit so that you are a bit more careful. The second material is this. For the goal and assignments, there's a really nice and easy to read reference book. and I liked it a lot. It's written again in a very easy way. So it's, it feels like it's very easy to learn. So it's called the Introduction to Introduction to Programming in Go by Caleb. Luckily, this textbook is freely available online. This is extended version. It's a physical book, I think published by O'Reilly. If you're rich enough to purchase the book, hey, welcome. If not, a slightly concise version of it is freely available online. Additional material, slides, and the videos are all going to be accessible from the course page. And I'm going to show you next where they are. So this is the end of the admin information. But let me show you where things are. So this is again the course page. So discussion you see already yesterday. Clicking it takes you to the FB group right there. All right, and I see that there are quite some of you have already joined the Facebook group. That's great. And so you see the link for the live video for today. That's wonderful. Now, second link, admin. Okay, you see also where and how to reach me and the TA. And you see also the distribution of the grades. Now, that page should be done for the rest of the semester. Schedule, okay. Now, this is important. Let's go over this a bit more carefully. In the 2 slides where I show the schedule of the semester, I did say that PA1 is doing week 2, PA2 is doing week 3, but I did not tell you exactly the day and the time. You see here on the schedule page, PA1 is doing March 13th at hour 18, minute 00, second 00. All right, so for PA2, March 20th. So I think all of them are on Friday. That is saying after you finish attending the lectures on Thursday, spend some time and then work on it and submit on Friday. Now that's a bit risky. So you might want to start a bit early. For example, at the end of this week, try to look up PA1, what it is required to complete it. All right. Oh, by the way, there's one more thing that's important on the schedule. Midterm exam and final exam. Okay. Midterm exam is going to happen April 23rd. Okay. At the exact hours of the lectures. So starting 10:20 to be exact. And it's going to end after 100 minutes. Final exam, June 18th, starting exactly 10:20 and ends 100 minutes later. Now let's see. Let's go over all the links. How about that? Videos. Here. Week 1, which is March 4th and the 5th. If you click into ep1, that actually takes you here. To the video that I recorded yesterday, okay, to make up for the students who missed the first lecture, all right? And later on, this live stream here, okay, will be collected and edited a little bit and put up also on YouTube, and the link will be added to this ep2 link here. For now, it's empty, all right? So similarly for all the lectures coming up next. And the live link, I'm sorry, I'm going to just post it on the FB group as that I'll be creating them before the lecture. Okay, maybe just half an hour or an hour before the lecture. So it's important that you join the Facebook group. And usually you receive notifications from the Facebook group conveniently. Okay. So you don't have to come here and check what is the link for today, you see. Now, assignments, there, the programming assignments. So if you click here, programming assignment number 1, you'll see the description for PA1 is already there. The fact is that it's actually quite long. But don't worry, much of it is just to set your mind so that you are more comfortable working on it. Okay, the assignment actually shows at the end of page 2. Okay, and going all the way to page 6. All right. So later on, I think maybe Friday or Saturday, there's going to be a video that takes you through the programming assignment. And I'm going to playing hands-on, like I'm showing now, to demonstrate typing one command and what leads you to next. So that it's easier for you to just copy what I did. PA assignment number 2 description, not yet there. Okay, so expect them to show up as the semester progresses. Now there's this link called the port assignment. Now this is needed beginning from PA4. So don't worry, when the time is closer, the link is going to be put up available. Next, exams. Right. Yeah, as I mentioned, some of you might worry that it might be hard, the exams. Don't worry. So the all exams are all available starting starting 2003 all the way to 2019. Yeah, let me do this again. 2003 all the way to 2019. So just click into it. That shows the midterm exam for last semester, in fact. Okay. The first question here is, consider a micro-internet consisting of 5 subnets, namely V, W, X, Y, Z. So where's V? V here, W here, X, Y, Z. Okay. The questions are, which of these subnets is classified as an institutional network? Okay. And which of this is a residential network? And which of this is a mobile network? Okay. And you see, conveniently, the simple solutions. All right. So feel free to dig in, spend some time with it so you get a feeling. Grades. So your grades, as we finish grading, they will be put up available as well. Right now, the file is not quite there. It's going to be an Excel spreadsheet. Okay, you'll see clearly as the semester progresses how many points have you earned. And that's all for the course page. So what I have provided on the course page is this: the book about Go language, Introduction to Programming in Go. The free version is right here. So if you click in, it takes you to the free book, as well as the book that's extended beyond the free book and published by O'Reilly. So let's see. There, yeah. This is the PDF of the course, of the textbook. So I actually start by teaching you where files and folders are in an operating system. Okay, and it actually introduce text editors you could use to edit your code. Okay, if we go up one layer, you will see also, hey, how you set your computer up. Okay, so that you could do compiling of your Go code. So explore. Now let's move back to the lecture. How do I exit this? There we go. All right, so I'm sure that some of you have questions. Feel free to post it in the live chat. Maybe it's a good time that I go check things out. All right. Wow, okay. Is the posted quiz one to be completed before or during class? No, it's not. It's expected to be completed by next Friday, now you know. So, Rocket Liu, I hope that addressed your question. Okay, Jian Han has the same question. Wei Cheng, is the deadline for quiz also at Friday 18:00? Oh, yes. Now you've seen that I go through the quiz part of the assignments. Let's see, but that's next Friday. So what? Let me see. What day is today? It's March 5th. So this Friday is March 6th. So the due time for quiz number one, which is coming up, will be 6 plus 7, 13. March 13th. Okay, and 18:00 exactly. In PA7, do we need to write some HTML programs? No, no. As a server, you don't really need to render HTML files. As a server, you just need to send back an HTML file. In PA4, however, there'll be a HTML file that you will need to use to sort of find out what's the file size and what's the content in the file. So in a way, Jian Han, for PA7, you need to generate some sample HTML files, okay? Oh, cool. I am sure that there's a certain delay. I begin to see things, and this is from Wei Cheng. That's probably because I say that it's Friday 18 hours, but next week. I tested. The delay is actually higher than what I have expected. I think it's probably more than 10 seconds. All right, so far so good. And I appreciate your patience. I think taking a lecture like this is very unusual. I'm learning to adapt to it, so please try to adapt to it as well. We don't like the virus, but unfortunately it's here. Now, if you feel more comfortable posting questions offline, feel free to go to the Facebook group. Just post whatever you have on the discussion group. For example, trying to form a group, which is what you'll be doing right now. Okay, let me bring up quiz number one. Quiz number one. Step number one, form a team of 1 to 3. And then work on answering these questions. First, can you write poly email messages in Chinese? Careful. Then, what exact day is the midterm exam? How much penalty for PA1 if you submit it on March 13th? 16 hour, 00 minute, 01 second. Can you type up questions in Chinese in the live YouTube sessions? Oh, that's a trick question. Okay, go back to the slides yesterday. So, form the group, work with your teammates. It could be fun. And for international students, it's also an opportunity to meet other international students or, get to know some domestic students, make friends. And then post your answers as a comment to quiz number one pick in the FB group. So make sure that you type up the names and student IDs of all the team members, as well as your answers. So let me take you to the FB group so that you see exactly where you do this. Let me bring back this, the web page. Discussion links here takes you to the FB group. Oh, wait, there are a lot of people wanting to join the group. Let me see. Let me just add them in. Approval. And back to the discussion. All right. Oops. Okay, very good. There's our team one, I see. If you scroll down, there's this quiz and solution submission collection here. Okay. Right now we have only quiz one. Okay, click into it. You see exactly what I was showing there, okay, in the quiz slides. And over here at the comment section, Polyos already demonstrate. You put name and student IDs of all the team members, and then you provide your answers to these sub-questions in quiz one. Okay, and nicely we have another sample here. Leo, okay. And I'm guessing that you are a one-person team, but I can with okay. So the answer for these four Qs are, slightly extensive. It's okay. Okay, I'm gonna take some time to read them through and see if it's acceptable. Very good that you are providing answer and justifying your answers. Great. Now you see how it works. Now, Liu Qiande, Leo, if later on you find a teammate, feel free to reply to yourself so that you kind of, extend your team, all right? But what I can say is that Leo, you'll be team one, and whoever join you will be part of team one. Okay. And that's, hey, exactly the time for a break. So we'll take 10 minutes break. Come back in 10 minutes and we'll continue the lecture. And starting from chapter 1. All right. So excuse me for going out to have a drink or going to the restrooms, the ladies' rooms, for a few minutes. And you guys are feel free to go offline as well. Where are my lecture sites? Ooh. I mean here. Ah, there we are. Good. All right, so let's come back to the lecture. So this is chapter 1. Well, before I actually start, let's try to exercise a little bit, okay? Although that we cannot be exactly very interactive, but let's see if we could still try to do some sort of brainstorming. Good. So what I'm providing here on the slide is a list of all these terms, okay? They should all sound very familiar to you. And some of them could be confusing, okay? Let's see. Human, calculator, computer, system, device, network, communication, information, and data. Now, think, okay, for maybe a minute. Can you group these terms together and somehow? Now, type it up in the live chat if you want, okay? So I'm gonna also think a little bit for a minute, all right? Device. Yeah. Yeah, what do you have? Let me see. Retracted. It's okay. Yeah, it's gonna take some time. So maybe what I can do is to share what I find reasonable to group the terms. Okay, you keep thinking about it. Okay, this is just Polly's language IQ. I mean, you might have a higher IQ than Polly's. So as long as you can justify. So this is what I find. Human, calculator, computer, systems, and devices. There are all these entities, so individual hardware. Okay, well, human beings, it's hard too, so hardware. Don't be surprised. I mean, we compute just like computers compute, all right? Systems or devices communicate just like human beings communicate. So I find a lot of similarities among these entities. Now, I find network, this term slightly different, okay? Usually it meant to indicate a group of something, okay? So for example, a network of human, a network of calculators, a network of computers, okay? So I see that a network is something that is a group of these entities. And then now, having multiple entities being connected in a network, then they can begin to exchange things, okay? And so this phenomena of exchanging things, interacting with each other is called communication. For example, we being connected in the cyberspace are also trying to communicate. So there's communication going on. So communication over the network of humans, okay? So in this example. And the stuff we're trying to exchange are often called the information or data. Okay, so I'm pretty sure that what I'm communicating is more information. Okay, data more specifically mean numbers, a collection of numbers, having structures. Okay, but between computer systems, a lot of times what they're exchanging are just data. All right, so information data are the things that we communicate over a network of entities. Right? Make sense? Good. So this is just to sort all these terms out that have been previously a bit fuzzy to you. Okay? Communication is not exactly network. Okay? Network is not exactly a computer. Okay? Information data, they are, serving the same purpose, although they are slightly different. Hope that we get these terms clear. And now let's move on to this. Before I introduce computer network, I would like you to think the human network. Okay, we getting to know each other. For example, you guys are trying to form teams. Okay, those who are in the teams are connected. You form a network. Okay, so essentially, a human network is that we're getting to know each other and becoming connected. Now, with that notion in mind, then it might be easier for you to think what a computer network is. Yeah, grouping networks, having these computers, grouping computers, so these computers are becoming connected. Yeah, but you know what? A network of computers could be the right thing to describe what a computer network is. But there's some subtle difference in the context of this course. So the answer here, I have to say that a computer network, whether it's a network of computers, yes and no. Okay, yes in terms of this. Generally speaking, okay, literally speaking, yes, a computer network is a network of computers. But professionally speaking, within the context of the semester, within the context of this book, okay, what we meant by computer network is really the internet. All right? So just to be clear. But that is also saying you can try to define or design your own computer. Okay? And it could be running a mechanism that's not being used by the internet. Okay? But it will not be the computer network, the internet. Okay? It might be called something else. Okay? Cellular network, that is to indicate the wireless network, the wireless phone network. So this actually helps you to think about what I am trying to teach here. Okay, so in the long term, is really to try to train you guys so that you can create your own computer network. Okay, generally speaking, but in the short term, you learn this computer network, the internet. Okay, you have to start from somewhere, and we might as well start from the most popular example. That's what I'm trying to say. All right, officially, chapter 1, the introduction. The goal here is, well, okay, let me say it the other way. The expectation is not high. The fact is that after going through the chapter, you will feel that, at some places confused because nothing is really going to be clear because the details are yet to come, okay? So what I'm going to do is to tell you, hey, this thing is called this term, that thing is going to call that term, and give you a couple examples so that you get a feel of, what things are, okay? And so you also capture the terms that I'm going to use, and you can relay what I meant by saying that word, all right? More detail is going to come later in the course, so bear with me, okay? So most of the things that I'm going to say in chapter 1 is just going to be very descriptive. There's not going to be much reasons there to support what I'm saying. All right. So in a way, for many of the things that you learn here in chapter 1, you probably need to memorize things a little bit. Okay. So much of the context is about the internet. Breakdown of the sub-chapters is such. So the first 4 is to talk more about what internet is going to look like and how internet functions in general, very high level. Particularly the first part, this is more the hardware view of the internet. So internet has this physical part, computers being connected by cables. And beyond computers, there could be APs, wireless APs that help us connect to the internet through Wi-Fi. And there could be routers inside, further connecting us to the rest of the world. So physical view of the internet. And then protocol. This term is actually a bit abstract. What it meant is that To operate this physical infrastructure, you also need something like an operating system operating the hardware of a computer. And that operating system for the computer network is called the protocol stack, because there are multiple protocols there to support communications of all these entities, physical entities on the internet. All right. Now 3 and 4 is to take us, so we kind of zoom in one layer closer to the physical structure of the internet. So we're going to divide the internet such that there's this edge part, the outskirt part, and then there's the core part. Okay, and the reason of this separation is because the edge part of the internet works quite differently from the core. Now, the rest of the 3 subchapters, sorry about that, they are somewhat independent. It will sound less relevant to each other and less relevant, in fact, to the first 4 subchapters. First is we're going to talk about performance. This is important because, hey, look at this protocol. So these are the mechanisms supporting operations of the physical infrastructure. Now, why we choose to communicate the physical structures this way versus another? Usually, we choose one is because it works better than the other. Now, what does it mean that it works better? Right? So we need to have these metrics so that we can quantify and saying that, all right, in terms of loss, this mechanism is going to work better, meaning less loss. In terms of delay, this mechanism is going to allow communication faster. Protocol layers. Okay, so there's nothing really technical in this subchapter. As I mentioned, as we go through the sort of preparation sites, admin information, I said that, hey, the scope of the course is going to be the internet. And we're going to cover it, from the application layer all the way down to the link layer. The thing is that network engineers like to talk about the internet in terms of layers. So this subchapter here is to explain why the internet, is always talked about in terms of layers. So it sounded a bit like that the internet is almost like lasagna, right? There are layers. All right. And the last, network under attack. Okay, so this is going to be a very sort of dangling subchapter there, because computer security is actually something that concerns our everyday life. Computer network security is even worse, in fact. We need to worry about a computer, whether it's safe, it's because we are connected to the internet. And therefore, it's easy to contract computer virus. Okay, so in that subchapter, we'll learn also some of the common attacks. Okay, this is just so that you get some common sense and perhaps you know a little bit better how you protect yourself. All right, let's move on. Good. So chapter 1.1, what is the internet? So this is going to be the physical view, the nuts and bolts view of the internet. Therefore, I'm bringing out a picture. All right, so what you're seeing here is, a network. There are all sorts of entities. So let me start from these entities that's connecting each other to form the network, particularly these part. All right. They are called, for example, this guy here, the PCs. The PCs. And these squarey boxes, they are servers. And they are drawn this way is because that usually the servers does not require display. So you just see this, box of computers. And then very commonly laptops. And nowadays, there are probably more entities, more devices connected to the internet using these. Okay, so these are smartphones or handhelds. So pads are also handhelds. Okay. Now these things, there are a high number of them. These days, probably billions of them already. Okay. All of them together, we call them hosts or end systems. Okay, so there are systems sitting at the end, okay, of the internet. And these are also the devices that are running these network applications. And these are also the devices that users use to access the internet. Next. To access the internet, the first thing the devices or the host or the end systems connect to is this, the communication links. Okay, some of them we see physical fibers. So for example here, this is an Ethernet. It uses copper wire. But some of these links, for example, inside the center of the internet, those require higher bandwidth, higher data transmission speeds. Then they could be using optic fibers. But this is not the access link, by the way. Okay, but this one here is access link. Now, these communication networks can also be wireless. Let's see, where are the wireless links? Right here. There's one here, one more here. So these are typically the Wi-Fi. We call these triangles the access points, specifically Wi-Fi access points. Now this tower here at the top, this is the cellular AP, okay? The telephone network access points. Now the differences between these communication links or access network is mostly in terms of the transmission speed, transmission rate. There's a specific term for it called the bandwidth. All right. Now, if you come from the EE background, sorry guys, bandwidth in some of the courses in EE curriculum is referred to as a range of frequencies. So when we talk about signal transmission, we also talk about what is the range of the frequency being used to transmit signals. Okay, so in that context, we call that range the bandwidth. Usually the wider the better, so that you can modulate more signals. But in this course, in computer network, by bandwidth, we actually meant the transmission speed. Okay, so the unit is always bits per second, for example. The last component, the routers. Okay, so they are here. Towards the center of the internet, so inner layer of the internet. Okay, so they are drawn this way: circular box with the cross in the middle. Okay, so the cross there is actually to mean something. Cross there means that it's exchanging. Okay, so these routers are sitting in the core of the internet, trying to exchange data all the time. Okay. So data go through here and come back here, for example, here, here, here. Okay, so you see here, the routers in the middle of the internet often have multiple connections to each other. You see. But if you go back to the end systems, server here, there's just one connection to the network. This server, one connection to the network. These laptops, one wireless connection to the network. See? Now, we talked about end systems, PCs, laptop, smartphones. Nowadays, there are even more devices being connected to the internet. There's a buzzword recently that is called the Internet of Things, or Internet of everything. Okay, what it meant is that, for all these other things that are not typically a computer, okay, as long as they're connected to the internet, let's just call them IoT. Okay, so my favorite example is this one over here. Okay, look at this toaster. All right, it's connected to the internet. The way it works is this, when you get up, drop a toast into the toaster. When it's done, the toaster is gonna imprint the weather of the day. So it's connected to the internet so that it can download the weather information from the forecasting services. So for example, this toast here is indicating today it's gonna be sunny. And if you see a toast coming out this way, that means it's going to be cloudy. And for today, so it's going to come out rainy, I guess. So it's a cool gadget. We don't see this quite yet, but it's actually on the market. One can actually purchase a internet refrigerator or a smart fridge. I've heard reports saying that, hey, the fridge here can actually order milk proactively for you when it sees that the milk bottle is close to the bottom. Okay, the milk is close to the bottom. Milk level is close to the bottom. So just so that you know, there could potentially be billions of these end systems being connected to the internet. Now, these entities, on top of them runs these things that I've already mentioned, the protocols or the mechanisms. They're controlling the sending and receiving of information. Now, on the computer networks, we like to call them messages. Okay, I mean, there's no why. We just like to call them messages. Okay. Some of the well-known protocols are TCP, IP, HTTP. You heard me saying it already. Okay. Ethernet, you probably see it a lot when you purchase a computer, when you purchase an AP. And next, you see, the internet is really, structurally speaking, a network of networks. Look at this. Isn't this a network? We actually call it the mobile network. This one here, a home network, a residential network. This one here, an institutional network. Regional ISP network, global ISP network. Each of these is a network already. And the internet is actually a network of the networks. All right? So overall, the internet is loosely hierarchical. You will see more. It's not very strict. Like, certain network is going to be higher hierarchy than the others. It's quite chaotic, I have to tell you. Now, and part of the internet is public, which means that you get free access. But there are now very, very rare of these public internet sites. Most of the internet is private now. Okay, so in order to access internet, you pay a certain amount of money. So you thought that using the NTU campus network is free? No, well, it's actually part, okay, of the tuitions you're paying. All right. All right. Now we are actually moving slightly towards the software side. All right. So the first thing, the whole thing is the internet or partial internet. That is the communication infrastructure. They need to be there to enable all the computation, all the communication that's needed. Okay, so these applications will be running on top of the communication infrastructure, running on top of the physical internet. Now these applications, by default, being distributed because you need a client side somewhere on the end systems, for example, here. And you need a server side somewhere running here. And this might be a web page access. Okay, you request for a web page and a response sent back from the web server. And so that is the application called the World Wide Web. And you could be using Line to call each other or Skype to call each other. And that's an VoIP application. Some of you have already sent emails to me. That's email application. And I don't have to say this more, right? I'm pretty sure that you play games. You just don't need the professors to know. So games, especially online games or mobile games, are also distributed applications. E-commerce, do you do banking online? I'm pretty sure that some of you do already. File sharing, of course. Web, in a way, is also file sharing, right? You're sharing HTML files, you're sharing PDF files, right? So communication infrastructure enabling all these applications. Now, these applications are actually provided by some communication services or protocols that's running underneath the applications. So some of these services provide reliable delivery, meaning, hey, you implemented a web server and there's a web client there to send messages. Okay, some of these channels you set up to send messages can be reliable. So it's a guarantee service such that there's no packet loss, such that there's no message loss. Okay. But some communication services implemented on the internet could be this, unreliable. Now, we often call these services the best effort services. It's somewhat contradicting here. Best effort, it seems that someone is going to be doing the best. How can it be less than reliable? Yeah, I know it's not exactly intuitive, but think the other way. If you run into someone and someone is asking you for a favor and you are not sure whether you can do it or not, what do? To be polite, what you say is, well, I'll try my best. Okay, so I think best effort there, okay, the computer engineers, the network engineers trying to refer to is more like that. A polite way of saying that, hey, this is not going to be a reliable service. Okay, and for your amusement, TCP is the protocol to allow reliable data delivery for an application running on top of it. And UDP is the alternative service as opposed to TCP, but it is a best effort data delivery service. All right, so TCP there, UDP there, I just mentioned earlier, HTTP. Each one of these is called a protocol. Oops, sorry. Each one of these is called the protocol. So this term here is actually more general than a protocol to run between the computers. In human society, there are oftentimes these implicit human protocols that are running between us. For example, Alice here saying hi to Bob. Bob says hi back. Alice asks for time. And Bob here says, okay, it's about 2 o'clock right now. Okay, so this exchange of greetings and asking for something, replying something, is also a human protocol. In fact, what we do a lot is, hey, for example, on the live chat window, you ask a question, and when Polly sees it, Polly provides an answer. Okay, so Q&A, that is also a human protocol. You might see quite a bit of these human protocols, except that we don't have a strict definition of it. Inside this course, in the rest of the semester, you will see a lot of these computer protocols running, being designed and being defined, and they are very specific on the other hand. So here, an end system setting up a TCP connection by sending first a request, and then the server sends TCP connection response. The client then sends an URL to request the page. The server sends back the page being requested. Okay, so this altogether, in fact, is HTTP. Okay, but this part here is HTTP, while this part here is TCP. All right. So a protocol in human society, you could have a protocol to ask for the time. You can have a protocol, in the live chat to ask a question. You can also, introduce your friends to another friend. Okay, so introducing each other. Hi, Bob. This is Alice. Alice, this is Bob. Network protocols is actually similar if you think about it. It's also to allow machines to be able to understand each other. Okay, so all communication activities on the internet is governed by these definitions of how computers communicate with each other. So messages need to be understood by each of the computers. You can probably imagine why it needs to be clearly defined, because computers really, if you think about it, they are really dumb. Unless somebody else writes, and runs an algorithm there to enable some level of intelligence, right? Now, AI is to try to enable computers to behave more like human beings, to behave more intellectually. But, enough of AI, this is computer networks. Just to ensure the computers to understand each other to send messages, you do need protocols here. Define clearly what the message formats are and the orders of them being sent. Okay? And upon receiving these messages, what actions these receivers need to take. Okay? Usually, in turn, sends back another message. Good. That takes us to the second quiz. Let's see. Oops, not quite here, but where's my quiz site? Oh, right there. So this is quiz number 2. All right. So, hey, Polly likes reading random things a lot. Okay. There's once this article I came upon on Wall Street Journal, but it's quite a few years back. It's called The Delicate Protocol of Hugging. So you see, the author there, the reporter there, used this term protocol for human interaction. All right. So what it says essentially in the protocol is this. It's actually complicated to greet each other. Okay. Americans like to hug each other. Mm-hmm. Latinos or Europeans like to kiss each other or touch each other on the cheeks. And some Europeans touches 3 times, and some Europeans touches 2 times. Now, Japanese like to bow, so they bow a lot. That's a way of them showing sincerity to each other. In Taiwan, well, sometimes we shake hands, but really, right, in everyday life, how do we greet each other? To show, that we are friendly. Mm-hmm. So it's actually complicated. And what makes it even more complicated is this. When it's, for example, if we are hosting a party where there are international students and domestic students, and international students are coming from different areas of the world, how do you interact with each other first? How do you, show a nice gesture, a friendly gesture? I want to make friends. Mm-hmm. Hey. Now, general rule seems to be that, to be polite, we do as the others do, because, if you touch cheeks with Taiwanese, it could be a bit offensive, especially if you touch cheeks with a girl. All right. So now, hopefully you're, somewhere in the middle of forming the teams. Once it's set, finish quiz 1. Now come back to quiz 2. Think through with your teammates. How do you know what you should do? Should you bow to each other, shake hands to each other, hug, or what? All right. So think it through, discuss it through. See if you can come up with some sort of algorithm so that dumb human beings can also find a way to hug politely, okay, without offending each other. All right, so that was quiz number 2. And let's try to wrap up what I intend to talk about in chapter 1 today. Good. So earlier I've said that, hey, if you look closer, the internet is actually a network of networks. Look at this. This is the network edge, the end hosts, in fact. And we see that there's access network. Communication links allow the edge of the network connects to the access network. And then each of these form a smaller network. For example, as I mentioned earlier, this is a mobile network, this is a residential network, and this is an institutional network. And these are ISPs. And together, they form a network of networks. Okay. And now, you see also at the center of the network, Most of them are routers, and they are also called the network cores. Okay, end systems essentially the network edges, hosts running the applications, end systems running the applications. Access network connecting the edge to the internet. There are all sorts of communication links, wired or wireless. Internet core or network core, there are a bunch of these internet routers and eventually form a network of networks. Right, so that should give you a rough idea of how internet is like physically. Let's dig one layer deeper to the network edge. So these end systems together or hosts together form the network edge. They are there to run the applications. So we've seen some example. That's great. What we don't know quite yet is that between these end systems, there are multiple models for communication. The first one, which is the most common one, is this, the client-server model. And you probably hear me saying this a lot. In fact, when I was going through the PAs, PA3, you need to write a client program. In PA4 and on, you'll be working on a server program and gradually extending it. So in the PA, we'll be creating client program and server program, and these two programs is going to be sitting on different machines on the internet, and they're going to talk in this model, communicate in this model, client-server model. Okay. And typically, client hosts requests and receives services from the server. So client here, server here, this guy request service, and this guy here return responses. And these servers should be always on. Otherwise, it's actually a shame calling it server, right? It would not be good service if the server works sometimes and now at some other time. Okay, and that probably give you away why I don't use sidebar. Okay, all right. So, hey, web browser is a classic example of a client, and web server is a classic example of such a server. And World Wide Web is an application that runs in this model. Email client. So nowadays we use a browser to read emails. So that browser is your email client. But there are email servers somewhere sitting in the internet. Your interaction from the browser to that server, for example, fetching emails, for example, sending emails, that is also running in client-server model. The alternative is this. Some of you might have heard about this model, the peer-to-peer model. What does peer mean, right? Now, if you think about your classmates, would you call them your peers? Probably. Most likely. But hey, how about Polly? Would you call Polly your peers? No. You probably don't call professors your peers, right? Between student and professors, well, the service is probably more client-server. But among you guys, if you try to address questions from another classmate, you are serving the classmates, but that kind of service is peer-to-peer, all right? So there's minimum use of a dedicated server. So there's no allocated and fixed amount of time, not always on. So the service is more at the same level, fair, peer-to-peer. So there's one very popular service, BitTorrent, BT. I don't know if you're still using it. Its use is declining because of the content being distributed there. But it's a file sharing system. It works pretty much like the web, allowing you to download big files efficiently. And Skype, this is VoIP. The way it sends voice as messages is very peer-to-peer. So we'll learn about these a bit more in the semester later. Now, end systems, they work in two different models. The end systems need to get through these access networks before they can interact with each other using different models. So access network is the next topic. So the question here is, how do you connect the end system to the edge routers? You heard earlier that there are different communication links. And in fact, for different subnets or different local area networks, they might be accessing the internet through these access nets using different communication links. So residential access nets, so residential here is here, okay. What's very popular there is ADSL in the older time. Nowadays, you might be using cable modem, and some of you might be using the fiber services. Institutional access, which is right here. A lot of times we use Ethernet and Wi-Fi. Yeah, that's about it. Ethernet and Wi-Fi in a big company or in a big university. Mobile access network is this one over here. It usually uses higher range wireless wider range wireless network. Well, namely 4G or LTE. In the second half of this year, you probably see 5G working. Okay. Now, these different access network, different communication links operates at different bandwidth, meaning they transmit data at different speeds, some faster than the other. And by faster, I actually meant that within a unit of time, you send more bits. All right, it's not like, it propagates faster. Okay, so lights propagate quite fast, but sound propagates a bit slow. Just to differentiate what I meant by transmission speed, I meant number of bits per unit time. And some of these network access protocols allow you to send data through a dedicated link. But some of these access networks actually made you compete for the bandwidth among many users. Okay, you will see some examples coming up. So the first one is this, digital subscriber line, or AKA DSL. So what it does is to use the existing telephone infrastructure. Before there is internet, there's already the telephone network. Well, I'm sure that probably some of you never seen a real telephone. So let me bring my telephone here. So this is my office phone. I'm using a wireless phone, but really the base station of this phone is actually connected through the telephone cable to the telephone network. Okay, so there's an infrastructure existing. Okay, and DSL here is borrowing this telephone infrastructure to transmit data. Okay. And the bandwidth for sending data upstream is 1 megabits per second. For downstream, actually higher speed, 8 megabits per second. And luckily, the telephone line is actually dedicated per household, per telephone connection. Okay. Now, come back to the picture here. Let me explain again. So existing infrastructure is here, the telephone network. Yeah, so this is 30, 40 years ago, before we have internet. There existed already the telephone network infrastructure. Now, internet shows up, and it's running here. And the core of the internet, these routers being interconnected. But users are where? Users are here, sitting at home. We do want to access the internet, but we don't have a cable at that time to connect to the internet. So what we do is, hey, let's borrow these telephone cables so that we could somehow connect to the internet. All right? So you see, PC here, you typing out messages, it actually arrives first at this ADSL or DSL modem, What it does is to modulate the digital bits into analog signal, because the telephone network here is completely analog. So this cable here does not carry native digital data. So we convert that to analog signals and then allow the splitter or merger to modulate the signal with the telephone calls. And they're going to travel through the telephone link to this place, DSL AM. So this is the modulator, demodulator as well. What it does is to split the signal. If it's voice, go back to the telephone network. If it's data, go this way to the internet. And this is how we access internet using DSL. Similarly, when there's server on the internet responding a message back, it's gonna come here, and this guy here is gonna modulate the digital messages into analog and go backwards this way. And DSL here demodulates the analog signal and then extract the digital bits and then send it back to the home PC. All right. Now, the last thing here. You heard a little bit earlier here. Upstream bandwidth, 1 megabits per second. Downstream bandwidth, 8 megabits per second. That is because of this. This cable here, okay, transmits analog signals over a frequency band from 0 to 4 kilohertz. Sorry, not kilohertz, kilohertz. Now, when ADSL comes along, we try to divide the frequency band, partly allocated to the phone and partly allocated to data. Oh, no, I'm sorry. Sorry. Okay, go back. The entire frequency band is from 0 to 1 megahertz. And when internet comes along, the phone calls are allocated only a subpart of the range, 0 to 4 kilohertz. And the upstream data is allocated this frequency range. The downstream, this frequency range. As you see that the downstream is allocated a wider range. The capability of modulating more bits is higher than the uplink. And that's why you see the differences between downlink bandwidth and uplink bandwidth. And that is also why DSL here is more being called the ADSL, asymmetric digital subscriber line. And that asymmetric actually meant to indicate the bandwidth for uplink and downlink is not symmetric. All right. And I think it's a time to take a break. We'll continue next week, Wednesday morning, 10:20, to talk about the second kind of access network. It's called the cable modems. And the way it works is actually quite similar to DSL, except that the frequency range allocated for the original data the cable network is trying to deliver to the digital data we are trying to deliver through the internet. The frequency range are quite different. Therefore, you see a differences between the bandwidth that we see in cable network versus the ADSL. We'll talk more anyway. In the meantime, if you have some questions, feel free to post it in the online, the live chat. Okay, I'll see if I can address them all. All right, we do have something here. Let's see. Okay, some of you are already working on the question I had earlier, right? Words that you will group with. Good. So look through it. Wei Cheng was saying data. Oh, okay, it's very similar to what I had. So the question from Rocket is this: would a physical switch be considered as access point? I don't know. It's a good question. I would say yes, but the thing that I need to think it through is because there's no computers, no end system connecting to the internet using a physical switch. Yeah. Yeah, usually you connect it through a cable. I mean, it could be a direct connection. I think that's what you meant, Rocket. Uh, your end system and the router and directly connecting it through a fiber. Yeah. It's very rare, very, very rare that I can tell you. But I guess you can say so. Mhm. But nowadays, when people talk about access network, we kind of exclude this type of, this way of connecting, right? Access point, does it need to be wireless? Yeah, when we use the term access network, we usually mean the wireless AP. Yeah, access point. A, access, P, point. All right, I guess that's all. Now, yeah, feel free. You might be a bit shy live here. Feel free to post the questions on Facebook. And that's all for today. Go and have lunch. So let me just end the stream here.